Yay, welcome. And we are arriving at this modern performance testing panel. Welcome everyone to the ones that are tuning in for the StarWest 2023 event, platform, YouTube, and where else? LinkedIn. We're on LinkedIn as well. Welcome to this performance testing panel, modern performance, where I have a lot of experts piled up here with different perspectives. I hope. I have a good feeling that we will have interesting perspectives into how performance testing should be done, should be approached. And to make that more interesting, we are giving you, the audience, and the audience here in the room, an opportunity to share your questions, share your doubts, stress test all the performance engineers here in the panel so that they can answer your questions, tell you that little peculiar thing that you always wanted to know, that you were like striving to figure out. So we are, where am I here? So probably down here. There's a Slido, I don't know how to pronounce that thing. Slido? Slido code. Please access the page, enter the number, and make sure to post the questions. If someone else posted an interesting question that you think, oh, that's a good one, you cannot vote it. The ones that have more votes, we are going to prioritize them, and we're going to be answering them in that order. So before we begin, let's introduce our brave performers that are today with us. Bring an applause, yay! Everyone watching, if you can put likes and you can put all sorts of things, that would be awesome. So that we can tell them, you're getting some love from the people. So the first, I'm not in a particular order, just because he's next to me. Welcome, share with the audience, who are you and what's the deal with you?
Awesome. Thank you, Leandro. Hey, everyone. My name is Kaushal Dalvi. I lead the performance and resiliency engineering teams at a company called UKG. And what our group does is we are a team of about 14 people, but we have thousands of engineers. So our team focuses not directly working on the performance and resiliency tests, but building tools, solutions, frameworks, and enabling all of the engineers in our organization, whether developers or testers, so that they can take charge of their own performance destiny. That's what we do.
Sounds awesome. And next to Kaushal, who do we have now?
Yeah, so I'm Nathan Jakubiak. I'm a head of development at Parasoft. So we make testing tools for developers and QA, spanning from at the development level, static analysis and unit test tools, up till API testing, functional UI testing, service virtualization, load testing, security testing, kind of basically the whole test pyramid. So I have a perspective both from what we build for our customers, but also we use our own tools in-house. We have our own performance testing challenges that we have to solve, so I can talk to it from both sides.
Awesome. Now, next, who do we have?
Yeah, my name is Nate Lee. I am one of the founders and also VP such as they move to containerized or cloud environments. So that's one area where we've been trying to help people with observability and navigating complexity there. Secondly, I think I've noticed an emphasis on, like Bharath said, being able to do testing in realistic environments. The problem is heavily regulated industries like fintech and healthcare actually can't afford to do that due to restrictions placed in their environment. So that's why kind of focusing on realistic traffic. There's many different approaches to achieve that realism. You could use AI, but you could also, kind of mirror or shadow traffic, which is something we're seeing a lot of. And then the third is the ability to simulate dependencies. And so service virtualization, I think all of us here have actually some experience with that. I actually came from a company, ITKO, that did service virtualization heavily. But the ability to mock these backends and isolate subsystem is a critical capability, especially when load testing, in order to move quickly and also see what your scale is without that payment processing system weighing on you or the mainframe causing you to slow down, and being able to simulate, speeding up and slowing down and do experimentation.
So I don't know if this is a trend yet, although I firmly believe that it should be. One thing that we focus on in our teams when we are performance testing our applications is, traditionally load and performance testing, you run this big test and then you have all this data that you have to analyze, right? And maybe AI can help us analyze some of those results and figure out what to do. But we're getting way more mature in how we do our testing, our automated AI API testing, and all the different kinds of tests that we know how to do. We're getting a lot more mature in how we do that. But I think we can do the same in load testing especially when we're testing more at a component level. If we want to test individual components, we could actually turn those component tests into automated regression tests for performance, where you establish SLAs around how that component should operate. And then you have a framework that allows you to measure that and basically give you a pass-fail indicator, red, green. Did it pass? Did it not? If it passed, I don't care. I don't need to analyze anything else. The analysis already happened for me. If it failed, I need to go look and do something. I think that for us at Parasoft, we use that internally for a couple of our different projects where the performance of our systems is important, because regressions in performance can happen at any time. And if we're not continuously checking it, we might miss it until it's too late. And now it's affecting our release. There's a big issue and everything goes haywire, right? So being able to turn a performance test into a small scale regression test, I think is something that a lot more people should be looking at.
All right. I'm going to flip it a little bit and going to talk about trends in not load testing. Meaning, all right, not really, again, a full-fledged trend yet, like you said before. And also based on conversations that I've had with other friends in the discipline, in the rest of the industry. A trend in not load testing is more and more a move towards having the maturity to do observability well. Meaning having the ability to do feature flags so that you're able to deploy and be able to shut things down if it starts blowing up. Having the ability to shape your traffic, to deploy only to 1% of the traffic and 99% of the traffic still goes to the original location, to be able to control that. And having very high levels of maturity in the observability of your solution so that you have sent the traffic to just 1%, you have that feature flag ready to go, you see odd things happening, you turn the feature off. And that way you're getting live, diverse, realistic data that you're typically not going to be able to reproduce in lab settings unless I'll change that statement probably in 3 months when AI has enabled that. And the other maybe trend-ish in not load testing is the focus on single user and the focus on the front end. And there's a lot more awareness happening, a lot more people are aware about the core web vitals. Google is also working on adding the next metric to that, interaction to next paint. And we have seen in analytics that even though your backend might be perfect, there are times when your front end is taking up 80% of the time. And that is what is leading to the perceived slowness in the performance.
So a little bit of holistic performance, realistic environments, different perspectives. I hear a lot of not only load, try to look some other perspectives. Those are lots of different perspectives because some are still hanging up on load. I think of when you were mentioning these massive load tests on production or in environments that we got to have something similar, how to work through that on modern cloud elastic microserviceable environments. But we will discuss a little bit more on that. If anyone watching wants to reinforce some of those questions, please do. We're getting some with lots of votes. So let's start with Gomati. We have the first question, most voted at the topmost, and was the first one that arrived. So hello, Gomati. We have her in the audience. Probably you remember that she was yesterday in an interview that we were doing with her. And right after half of this session, she got to run because she's doing a talk the other day, the lady on the block. So from Gomati, what does performance mean to you? Ooh, this is a very big, I don't want to say kind of subjective question, depending on who you ask, but let's see now backwards. Kaushal.
All right. What does performance mean? I'll go back to the roots with quality and start with Joseph Joran's definition of quality, which is fitness for use. Because this conversation comes up sometimes that functional quality is more important and performance and some of the other abilities have to come later. And how do we tackle that? How do we divide the time between these? So I go back to the first principles, to the root with fitness for use, and say that the application of the system needs to be fit for use for whoever are the users, and all the different abilities, including quality, need to reach a certain level of threshold to be considered acceptable for use. You could have a system that works perfectly well functionally, but it takes too long to respond. It's not fit for use. You could have a system that responds instantly, but gives you the wrong answer. It's not fit for use again. So performance is amongst all of the attributes of the healthiness of an application. There was the COPRM DSO 1970s definition of quality from IBM: capability, usability, maintainability, performance, reliability, installability, documentation, and availability. So I don't want to call out performance above or below anything else. All of these things together need to reach a certain threshold for fitness for use. That's my view on it.
Very good, very good.
Yeah, I actually like that fit for use. That captured kind of what I was thinking, but your words were way better than mine. I'll give you two examples because they're very different examples, but like what it would mean for what we're doing in our organization. So we have a service virtualization tool that our customers can use to mock services, right, that are unavailable or hard to access. And sometimes they use them for load and performance testing. And so they need to be able to handle very high loads. And so in that particular case, we have certain SLAs, like tens of thousands of hits that we need to be able to hit with certain with certain kinds of payloads. Like it needs to hit that in order to meet what our customers demand, right, for what they're going to be doing in their environments, right? So for that particular application, we have these very specific SLAs on number of hits that we have to hit, and that's what that application being performant means. On the flip side, this is actually would not be considered. This isn't really load testing, but we have another application that will automatically generate unit tests for you by analyzing your code. We also want that to be, quote, performant, right? So performant in that sense is it's not a certain number of tests per minute because the code that we're analyzing, every code is different. What it takes to analyze it might be different. So in this particular case, it feels a little more subjective, like what's acceptable. So generally what we did is, okay, we measured, okay, how long is it taking? We objectively tried to decide, is that good or bad? We optimized. And then at that point, we said, okay, this is our threshold. We don't want to get worse. And so for us, performance meant we're not going to get any worse. and how long it takes to generate for this sort of benchmark, right? So it's a little bit different, right? It was not a hard and fast number. We kind of came to it by observing more than by setting out with a upfront standard.
For our customers, I think we're a bit more explicit. I mean, regression and functional testing is one thing. So we help our customers look strictly at performance. And for our customers, we're tending to look at the SRE golden signals because they're looking at monitoring data and saying, is this up, is this up to our standards? So headroom, which is like CPU and memory consumption of your pods and clusters, throughput, latency, and error rate, right? So those are the SRE golden signals. We're helping monitor those as we stress these systems. And it's not always their own internal APIs that are causing problems. There could be authentication calls that you're making to Auth0 Okta or Ping Identity that's slowing you down. It could be third-party payment processors that are falling over on your mobile ordering app. So we're stressing all aspects of the system and then isolating them using mocked APIs to really get down to what the bottlenecks are.
All right. I'm actually going to keep my sales pitch aside and then give you some pitfalls and why performance is important for customers, for users, for anybody. And I'm sure there are a bunch of Swifties here, right? I'm sure people know Taylor Swift. Last year, Taylor Swift and Ticketmaster had a big debacle, right? Ticketmaster did not have basically they didn't test or for scalability or in order to make sure that when folks are getting on Ticketmaster trying to purchase for Taylor Swift, their website crashed because they did not utilize the right infrastructure testing. They were not ready for the Autobots to just go and purchase tickets on behalf of people, right? That's the classic example of why you should do a performance test before you release something to production. Another example is I don't know how many people are here from New York, but the school district in New York, before you get to your approvals for the school, their website crashed, right? There are people not able to submit their applications in time, and then something happened. So parents were waiting for long hours in the New York school district before the school was about to start. So that's another example why before any product, fit for purpose product, whatever terms that the panelists have used, before they go to production, you got to make sure it's scalable, it's ready. It's ready for all those over there. It needs to be available. It needs to be readily available.
Very good. Very different perspectives. Some complement with each other. I feel like some conflict with the others. I saw some eyebrows being raised when some others. Anyone wants to comment on each other's perspective? Oh, come on, fight. No, I'm kidding. Yeah, you got me thinking with the Taylor Swift situation. It's like lately, my example, my excellence, why you should still be doing what I call the Vault big ass load tests, that you're trying to bring down the system that like Taylor did. And if any should be doing load testing most of the time, it's the ticket company thou shalt not name.
And I usually say this across whenever I go to meet customers is, for performance testing is not just an event. It's not just, hey, we need to get through this scaling event from dev to QA to performance to production. Performance testing is a situation, it's actually a process where you have to make sure you break the system. You need to know where your system breaks. You got to know when the applications actually go down. That's what performance is all about.
That's where I wanted to steer the waters a little bit, because to me, yes, super important. You will have Taylor Swift, you will have your Black Fridays, you will have your Obama cares, all of those things. But would you do that in a continuous fashion, pushing load to limits? I see already, like, want to comment?
Not disagreeing overall, but we've had this confusion around the terms that we use, because there are certain terms like reliability that has an IEEE industry standard definition, and it has very specific. But performance, there's no industry standard IEEE definition to the best of my knowledge. So we use performance as an umbrella term, and that's where I've found the conversation most useful, that performance is the umbrella term and there's a bunch of things under it. So for example, there's regular load type of tests where you're recreating standard traffic that you typically see. You take that, you stretch that, and run it for longer durations of time. That becomes your endurance test. Then you take your regularly observed traffic and you bump it up to see how your system is going to react. You go 2x, 3x, 4x, 5x, 6x. Now you're going to loosen your non-functional requirements a little bit. You're not going to stop the test just because your SLOs were violated. You're going to keep going to see at what point does the SLO degradation get so bad that it does not make sense to continue. That's your stress. Then you have your spike test, where you all of a sudden add 5x, 10x your Taylor Swift level load and take it back down to see, one, do you have a scalable system that reacts to in growth in incoming load by maybe auto scaling or have elasticity. You have database volume tests where you're keeping everything else the same, but now you're adding volume to the database to see all has been same system, same code, same everything. Amount of data is changing. How is my system going to react? So when I'm talking about those, I specifically use those terms because yes, performance is the umbrella term for me, and that's just how I do it. Because unfortunately, we do not have an industry standard. IEEE should really do something about that.
Nathan, I saw you just like steering a little bit.
Well, so I think what Kaushal is talking about is there's different aspects to performance or different ways to look at it. So a stress test will potentially expose different problems and be due to different causes than a spike, right? Where you just hammer it all at once, right? You might have a memory issue with a sort of a soak test where it's a different problem with a spike, right? So I think that's why all those different kinds of tests are important. Now, I talked about continuous testing. I wouldn't run all of those continuous tests constantly all the time. I don't think that's feasible. When I've been thinking about continuous performance testing, I'm thinking of a smaller scale. What's the word? It's a relatively low intensity where it's just like it's the kind of the base level of performance for this certain level of load. Does it behave according to how I expect? It helps me find it's easy to do. I can automate it. I can make it continuous, and I'll catch easy things, right? But like I talked about our service virtualization solution. We don't run that continuous, right? There's some things we might run weekly, and then there's some things we run even more because the amount of load we have to put is so much higher and the resource needs are so much higher. So those are not things we're going to run every single day. So I think you have to figure out for each kind of load and performance test, what's the optimal cadence, I guess, at which you should run them, right?
Ooh, I have some thoughts on that, but I'll come back around. Complimenting.
We actually do have customers that are running continuous performance tests. Part of the enabler there is really being able to simulate environments. So virtual services is a critical piece. But I mentioned some of the trends we're seeing, again, is on reducing cognitive load of the developers and then also segmenting off these back-end dependencies, right? And the reason I said those two things is exactly why we're helping our customers do continuous performance testing. One is engineers oftentimes may not know what backends they have. They may be new to a team. The documentation may be poor. I'm not saying we have bad documentation, but some of us are guilty of that. So sometimes it's just too hard to figure out what environments do I need, what databases do I need. And so being able to provide that data can actually help accelerate and get you to continuous performance testing. And then integrating these sorts of service mocks as a regular part of the deployment pipeline can allow you to do it. Because the hardest part about load testing is really feeling like you have to eat the whole elephant at once, but really you need to break it down into smaller subsystems of tests that you're running and just get manageable chunks. But the last part that makes it hard is it's typically a big bang thing that happens at the end of every sprint once everybody's done and the environment is available. So if you don't have a way to simulate the environment and a way to simulate the data, it's never going to be a continuous performance test. It's going to be a thing we do at the end, at the very last second, and you run out of time to do. So I think it's achievable, but there's a lot of lift, as Nathan mentioned. And if you're manually scripting those assets, it tends to lengthen things out.
In fact, let me tell you, before I joined Perforce and before he started SpeedScale, Nate and I used to work at the same company for the same product called SV. And then Nathan is actually working in the same, almost similar product, but for a different company. And bottom line is we're trying to solve the same problem: is how do we get continuous performance testing with constraints behind the scenes eliminated, right? Let's just take an example. Since we're at Disney, most of you heard about Disney streaming, Disney Plus that came out, right? How do you think they were able to scale at the same level as Netflix? It's because they have designed testing in a continuous fashion, meaning wherever they have to test against the mobile devices, they have to test against the platforms on the UI that you can stream them. But if you need environments to be available while they're releasing code, they need to have backend applications available all the time. When you're doing a full-blown performance testing, if certain, let's just say, okay, let's just take back. 5 years ago, when you look at most of the architecture, model architecture, it's not A, B, C, D, and D anymore. It's heterogeneous now, right? Applications talk to all over the place. They go from A to Z, Z to F. It's just an intertwined architecture now. When you have a complex, heterogeneous architecture, you need applications to be running all the time when you do your end-to-end testing, when you do your performance testing. And that's when these backend constraints come in handy. Is when you're doing a full-blown 1,000-user, multi-million user test, if one of the backend application fails, what would you do? You just have to wait for the developer to come and then fix it, right? If you have these constrained systems readily available, whether it's Kubernetes, whether it's UI, whether it's mobile-based, your performance testing continuously happen. And you kind of monitor those metrics throughout the cycle. I think, to me, that's the problem that we're all trying to solve.
Monitoring. You just touched on another interesting area that we may get into discussion, but put your questions, send them. There are some that I didn't think were going to be given attention, but they are being upvoted. So vote for the ones that you want on Slido. Don't miss it up. This conversation is getting heated. I love it that I see many different perspectives. No shouting yet. But we have a very interesting and a question that makes me roll my eyes a little bit, but let's see what comes. We have a question from Juan. I wonder where he's asking from. So the question is from Juan. What are the most important metrics we should check when doing load tests? So let's begin from opposite direction.
Well, I think for me, the biggest is the throughput, right? Which is transactions per second. As long as every time you do a performance testing, you're testing it against an SLA that's been set by a user, right? We're all trying to cater towards a user. Right? How fast when the journey of a user is when you get on a website or a mobile device, how quickly does the UI or the application renders fastly, and how quickly is the journey for him to perform that. So I think the main, I would say, are throughput, which is the transaction per second, and then obviously the average response time.
I think you guys already know my answer. I said the SRE golden signals. So throughput, latency, headroom, and error rate. But I do want to emphasize the headroom and the error rate. So we've seen with a lot of our customers, they just check status codes when they're doing load tests. We recently ran into an issue with a large retailer where the status codes were right, but there was an error message underneath, and that was getting through, right? So just because you're checking 200s doesn't necessarily mean that's correct. So you're going to continue sending traffic to that system that's sending back 200s, which is erroring out. Secondly, I think the promise of cloud and ephemeral environments, self-healing, elasticity, all those buzzwords kind of makes people relax, thinking, oh, well, if I just run out of pods, they're just going to spin up more. There's a lot of kind of optimizations and cloud costs that can be hidden in your pods, each unit of whatever platform you're on. So if you're not utilizing CPU efficiently, or memory issues actually can take down whole clusters, right? So you want to make sure that the CPU and memory consumption when you're running these performance tests is being monitored and optimized, and you want to track that historically. So if you say, hey, I made a logic change, it's using 20% more CPU than the last build, that's something you may want to look into because that's scaling across your entire enterprise, right? headroom constraints can actually bring down a whole cluster. It's not just isolated.
I think one thing that I would add, because it's hard to argue, I mean, I think it really depends on kind of, if you talk about fit for use, it really does depend on what you need to provide for your customers, which things you need to measure. So it's hard for me to say, oh, it has to be this one thing. All these things are good that we've been mentioned. But for whatever metrics that we're deciding, I think the averages are good. I would also look, though, at the outliers, because if you have a lot, I mean, if you have one or two outliers, great. But if you have a significant number of outliers, your average might be good, but you might actually still have a problem that's being flagged by the outliers. So I think that's one thing that I would look at, because that could signal a real problem, even if your sort of throughput's good, your averages are good, whatever metric you're looking at.
Good point.
Oh, you stole my point. How did you read my?
sorry.
How
Sorry
did you
about
read
that.
my mind? Nah, I'm just messing with you. No, but can't really argue with the four golden signals from the SRE book. Has become pretty standard. Latencies in percentiles, error rates, current traffic, being able to tell what you're currently experiencing, and saturation or headroom. So I'll expand on the first two, which are more tactical in nature. For example, like you said, the nature of latency data is that it is a long-term type of distribution. So there are going to be huge outliers either way. Percentiles help, so looking at 95th, 99th, but taking it one more step up in the level of maturity would be to have full histograms or box plots to be able to see the whole range of data, from what is your minimum, what does the typical experience look like, what are the outliers going to look like. So that's on latency. And for the second one, for error rates or availability, there's a shift or a trend happening where time-based availability does not really make sense anymore, because earlier there used to be big monolithic systems that it made sense that it was either up or down, and it was either up for 23 hours and down for 1 hour. That's how you would calculate time-based availability. But like you mentioned before, that the systems are really widespread right now. There's not really one small thing here and there. You have your own services, microservices. You're talking to third-party applications. There's things in different clouds. So overall aggregate availability has started to make more sense, where you're comparing successful requests versus total requests. So those are the metrics that I would call out.
I love it because that's a question that always appears on a performance talk, whatever. And I didn't see any consensus, like strong consensus, other than the SRE metrics. But there was an it depends, there was this, there was that, all sorts of flavors, which shows how, I think, malleable or different is performance depending on the situation or the standards, or from what perspective we are looking at it. I have another question from Mr. Anonymous. Yeah, we have a lot of questions from Mr. Anonymous. I don't know why. And this is whoever wants to get it. I think it depends. I'm going to leave it open. And if everyone wants to answer, how to check slowness in mobile apps? Anyone wants to jump at that?
I think I'll take a stab at the first one. I think it's quite difficult if you're not. So conventionally, I think where you're trying to validate the mobile apps is from the mobile app itself, and I think it's a different. I could empathize with people who are doing mobile app testing, trying to address the delays there, because most of the time you're running something like, and I have no skin in this game, so you're running something like Perfecto or Sauce Labs or a slew of mobile app testing tools, and you're getting the delay from the UI. But I feel like UI testing is similar to like a iceberg. You see just the part that's above the surface, but all the business logic, API calls, database calls are below the surface, right? And that's really the majority of the app. And the mobile piece changes frequently. So it's very hard to build automation that stays on top of that. So I actually would encourage systematically checking all the APIs as you do code commits, continuous performance testing, understanding how these subsystems play. So if this API is 20 millisecond delay, that one has 30 milliseconds, this one's 10. Well, the 30 is the slowest one. So in theory, right, that should be your bottleneck. But it's difficult to do without the mocking solution, right? As well as we've had numerous customers of ours that do mobile app testing, and 9 times out of 10, it's a third party that slows them down.
Yeah, mobile is an interesting situation. Go for it.
So this will probably not apply to large organizations that have native mobile apps, but mostly across the board in medium to small organizations, what I've seen is to save on effort. Uh, the native app is not the first choice, but something like React Native or any other JavaScript framework that is going to let you build a common code base and then build iOS and Android specific apps later. So if that is your specific situation, then one thing that we have tried to do is that JavaScript view can be brought up in a browser as well. And then the same tools that you use for browser-based testing on the front end and get front-end performance metrics, like the Core Web Vitals, you would be able to get that type of feedback. And with Lighthouse, the tool that's available in all Chromium browsers, you can also emulate a bunch of different things like the network throttling and even CPU throttling to make it feel like it's a older device with CPU, mobile level hardware, so that you're not getting blazing fast performance. Again, it's not perfect. It's not going to give you the same, but it gives you a way to track things over time. And once you create that correlation of what you see in these tests versus what you see in production, you will be able to say if things are getting better or worse.
I'll just add one thing. We don't do a lot of mobile testing stuff, but I like the idea of this sort of the iceberg, right? You don't know what's underneath the slowness. So it could be at the UI level, it could be at an API level, but if you test the API and the API is fast, now the one thing that we haven't talked about yet is, well, what region was I running my test from, right? Sometimes you're going to get different performance from different regions, right? So you might need to like test different ones and see, because maybe the bottleneck is in some delivery network somewhere. So you basically have to sort of try to isolate down to where are all the places where it could be contributing to slowness, right?
Add some flavors and spices from locations, because that's another interesting. I loved the perspective of using the browsers give you the option to test the browser version. Some performance metrics that are very interesting that sometimes we don't think about. Temperature. Has anyone felt that the cell phone in your pocket is turning you into some sort of breakfast bacon? Because it's getting so hot, the CPU, that's bad performance. Some of those other things are not always paid attention to, and it's part of the performance, the efficiency. Your battery draining is bad performance. Thank you, Anonymous, Señor Anonymous. We love your questions. So we have one from No here in the audience. Yay! Big applause for people in the audience sending questions. Yay! Thank you, No. So the question from our amigo No is, what is your go-to convincing argument that others could use for why performance testing is important when trying to convince a non-believer or to gain buy-in? Let's start now.
So I do a tutorial on performance, and this is the first slide that I open with. And I have 5 different use cases that I have listed down on that slide. It usually comes down to the fact that performance gets into the limelight when there is a huge blow up. And then there might be a little attention. After some time, it starts waning. So folks who have been having difficulty having that conversation, what I recommend to them is bringing in the business side and tying that to performance. That performance is not just these latency, throughput, or availability numbers, which do have an impact on things, but if you are able to tie that to business outcomes. For example, there are common studies where both Amazon and Walmart have published that 100 millisecond change on their checkout pages has as much as 1% impact on their overall revenue. So that puts things into perspective. There's BBC who tried to change the median load times, and they found that they were able to prevent user loss to newer sites coming up just by making the change for performance. Staples has published studies about how improving performance improves their conversion. Pinterest, Etsy, bunch of studies that I can think of, and that's the main point to call out. If you can tie how your business is going to get affected by the performance metrics, that's an easy argument to make.
Now you stole mine. This is a hard question for me to answer because I'm sort of like, why is performance not important? So I don't even know how to answer it. Maybe I'm lucky at the company I work at, but yeah, I would have to tie it back to how does it impact the end user? I think these sort of statistics that you talked about to present, if I had to, I would try to run something small on the side and prove, hey, look, we have a problem here. We need to do something about this, compared to what our competitors could do. Like, I would find ways to try to argue for it, like with evidence or like, but all towards this is how it could impact us if we don't do anything. Now I know if you're talking about like you have to do this huge stress test and something that would only happen if you had 1 million users, right? It can, those can be hard to get buy-in, but I think you have to tie it back to how does it impact our users and basically the bottom line, right?
I've spoken with a lot of companies that I've never needed that argument. So I'm like,
Lucky you.
I feel like anybody you talk to, you say, do you do enough performance testing? The answer is always going to be no. I think it always keeps people up. I think the better question or the better convincing you have to do is actually sell them on how to get started, because people think it's this giant discipline they have to roll out and they have to be masters. And really, I try to make an argument about, hey, like, what's the most critical API in your system? Like, is it the product index page? Is it the checkout? Is it the delivery API? And really just start with that API, mock what's around it, start generating realistic load for that system, and start small and load test. I think that's the better argument to be making. Anybody I talk to, if I say, do you do enough testing? Everybody, it doesn't matter if they've got armies of people doing tests. They're always like, no, well, I could do more testing, I feel like. So that's the argument I would be making, is how to get started.
Good.
Great points. But then I want to add to that argument. I usually use examples. One of them is the Messi effect, which is the Lionel Messi. We're talking to the MLS and then Apple TV lately, one of the customers, and they were not ready for the traction, for the number of people who are getting onto the MLS trying to purchase the products. The biggest argument is, if you do not test your environments at that scale level, I don't think, people will probably go to a different company or try to purchase products over there or stream over there, right? The classic example is any events that you have, Oscars, NFL, where people are trying to stream at the same time, the rate at which, the streaming has improved is one of the key examples why you have to do your performance testing on all the apps, native, hybrid, UI, doesn't matter, right? It's pretty critical to have these examples when you're going against the arguments.
Always translating. Don't you get like a Chicken Little perspective, or the people look at you like that until the sky finally falls, and that's when, like, I told you. That's very, very frequent situation. It's from the things that you were saying. I would say, like, I would do the question to management: do you want to be like Ticketmaster?
Exactly.
No, right? So we have a few questions that are. I'm going to go with another one. Juan, if you're asking, give me a moment, because this is another question that goes in a very similar line to what Noel just asked. How do you get the higher ups in your company, again, talking to manager, convincing the almighty levels, to address a known performance issue in the product? Because, I've been there several times, like, hey, we have a problem. Yeah, we'll check. But there's a problem. Yeah, we'll check. How do you convince management to pay attention to those or do something?
Throttle it. I mean, yeah, you could just, you don't know what you have until it's gone, right? So if you slow it down, but I guess the question more like, how do you convince your management to pay attention to that, like to providing more resources for that team, or is that more the question?
I think it goes along the line of just pay attention to it, do something. No?
So another thing I talk about is the Spider-Man line: with great power comes great responsibility. So for performance engineers, that I've shifted that a little bit and made a corollary that as performance engineers, we have the extraordinary ability to waste everyone's time. And what I mean by that is uh, workload modeling and coming up with the right tests and the right questions to ask. There are times when we do get that wrong, when you uh, are running tests way under what is going to happen in the real world. And there are times when I've done this 10, 15 years back, when I've run tests that would absolutely never happen in production. Uh, Maybe I got my logs and my forecasting wrong, and I've created those defects myself as well. So looking back at it right now, it makes sense that some of them were not prioritized and not taken up. So I'm playing the devil's advocate here and saying that if your workload modeling was right, if it tracks, if it is going to show up, there is going to be pain. And when there is pain, it will automatically get the traction it needs. If for whatever reason that particular defect that you've created around performance is not getting that attention, then maybe it is not painful enough. Maybe other things are more painful. Maybe there are accessibility issues that are causing compliance problems, and that might be a bigger fire to fight with limited resources. So have to be mindful of that.
So I'm going to approach it because I'm actually, since I'm head of development, I'm actually having to make those calls, right? So there's always a host of problems that you have to deal with, and it really comes down to where's the most risk, right? That's for me what I'm looking at. What's the most risk? So if you show me that there's risk, and there's more risk than all these other 10 things that we have to worry about that are also problems, then the higher risk ones are going to get the priority, right? So just from my perspective, it's all about risk. What's the worst case scenario that could happen? And again, but that's back to risk, right? How is it going to impact the customers? How likely is that to happen? Like all those things factor into making those decisions, which are the highest priority things, because I don't think anybody ever has time to take care of every single problem. I don't know. From my experience in software, that's never the case, right? So you're always picking what is the highest risk, what affects our customers the most. So you have to talk to me about risk.
Well, the last one, just to add, is the classic example, conversation about functional requirements versus non-functional requirements. Which one is the priority for that specific team? And obviously, functional gets a leeway in that, where NFRs usually take a back seat. But until
Sadly.
something blows up, which is exactly ticket muster, then you wouldn't go back and then say, hey, I think we need this in our cycle. We have to make sure that we test it against scalability, reliability, and all the terms that we've been putting out there.
I think there's an argument to be made about performance being a functional requirement.
Oh,
It needs to
that's-
be.
Yeah. We could have just a panel based on that.
Right.
They say non-functional is performance non-functional. Why non-functional? I hate that term. Sorry.
But
I-
it's getting embedded now into the whole continuous testing platforms these days, right? Now, as the code is released and your tests are getting created and everything gets populated pretty much at the same time. So
I will say I've been with a few customers that have had trouble figuring out what was the problem. What was the latent system? Is it the database? Is it this API? And I think true performance, I mean, we talked a lot about performance testing, but true performance engineering is actually quite difficult. It requires stable, predictable environments, experimentation, and tuning. And in order to track down which system it is actually causing the delay and to work on that is actually critical. And it's being able to mock systems and then take variables out of the equation is actually critical.
simply
say-
put, you have to break the system. That's the whole idea.
Not always. I would say
that's
it's
when you
fun
know-
too, but yeah, at times, and it depends. Based on what you were saying, sometimes the defect, they may be a reason why it's not being paid attention. Probably you don't see only your performance perspective, but this thing is slow. Yeah, but we are not processing payments. Well, shall we pay attention to that? Or vice versa. This is something really critical that Chicken Little again, and finally it breaks. And then it's like, told you. So we get a lot of told you moments in performance. So we're running out of time. We have just a couple of minutes. Let's try to do a lightning question. try to cover. I don't think we're going to be able to cover them all. But first, Juan, again, how do you get realistic environment with cloud elastic microservice-based environments to load test? I think you were. Who wants? Give it a shot.
One word answer, you don't.
Wait. Say what?
You don't.
I kind of agree.
Just being facetious. It is difficult. I don't have a good answer for that.
I mean, you just have to integrate with all the cloud providers out there, GCP, Azure, AWS, and then make sure that your environments are scalable in those, and in those cloud providers, and execute there.
I interpreted the question for like APIs that exist in cloud environments. How do you mock them? And my answer is you look at traffic, but I'm a little biased.
Yeah. And it's a different perspective. It depends on what you're doing. To me, it jumped the elastic part. Do you load test elastic? The builds from the cloud are usually interesting when you do those type of tests on elastic environments. That's like a double-edged sword, right?
Yeah, I mean, a lot of people have the illusion that auto-scaling happens instantaneously, but there is a warm-up time and there's a transfer, time for the new pods to spin up. And usually people wait for a high-traffic event to test those situations. You have to get proactive.
Yeah, that's the other side of the coin, because you need to test the performance of the elasticity, not only the system, and that's an important one.
HPA takes like 2 minutes.
Good point. Very, very good point.
I
Next,
think almost all of them take around 2 minutes. AWS, GCP.
last question. Let's try to kill it in a minute from Katsi. Katsi is here. Okay. Applause. Quick applause. Yay. Thank you for the questions, local questions. Okay. Do you see the conventional performance testing in the future, or are we moving towards APM-based solutions to achieve end-to-end observability?
I think that's what I started with for the first question. That is a trend, starting to see it. But like I said before, you need maturity in some other aspects as well. You need to do feature flags well. You need to be able to control the shape of your traffic. And you need to have really good observability, not just logs, metrics, traces, the 3-pillar definition, but really be able to tell about the internal state of your application just by looking at the external outputs without having to deploy any change. If you are able to do that, then you have real observability.
Yeah.
Actually, the trend is, according to me, but the trend is changing. It's what is called as the end user experience monitoring, where you test all of it. You test your UI, you test your applications, you test your backends, put all of them together. Will give you a holistic view of how the response times are for almost all of them. So
Thank you very much.
I think you can integrate APMs and UI, all of them put together. So
Modern perspectives. Yeah, quickly.
I think OTel and end-to-end monitoring and observability is actually really difficult, and I'm not sure it'll ever happen. I'm very opinionated on that. My co-founders come from companies like New Relic and Observe. We've talked about this ad nauseum, but I feel like specific API-based observability is actually a more manageable problem.
We left the can of worms for the end, but okay. So thank you, everyone. Thank you, everyone that is watching. And I'm glad to see that many people here. When we close the stream from the laptop, I want to ask for an applause, everyone. Thank you for the speakers. Thank you for everyone here. And I hope that you enjoy StarWest 2023. Keep rocking it and have fun. Gracias and adios.
Thank you,
Adios,
guys.
everyone.
Thank you.
Take care. Bye-bye.